for lifting heavy things, for carrying and then lowering material into the desired location. This kind of work requires a considerable amount of energy. Since the beginning of civilization, man has always been searching for ways to move objects which were too heavy or too bulky to be moved easily and quickly by sheer physical strength. Today, forklift trucks permit rapid handling of most materials and products. Simple, smooth manipulation of hand controls allows just one forklift truck operator to do such energy-consuming jobs as picking up, carrying, and depositing heavy loads, thus eliminating physical labor and reducing manpower requirements. Most forklift trucks have mechanical or hydraulic mechanisms for raising and lowering loads to be transported and for unloading and storing material. It is the hydraulic system that provides the power to do the work and permits smooth operation of the forklift truck's lifting mechanism. The hydraulic system, which is used to drive and control the lifting mechanism, is one of the most important parts that determines the performance capability of the forklift truck. The major system components may be compared to the heart, arteries, veins, muscles, and blood of the human body. Before discussing the mechanics of the forklift truck, it is well to review the basic laws of fluids. When force is applied to gases in confined containers, they undergo a change in volume, as shown at A in this picture. Liquids, however, are relatively incompressible, as shown at B. Even when liquids are subject to extreme pressures, the change in volume is almost negligible. This physical property of liquids is utilized by hydraulic systems to transmit power and to multiply force. Picture B also illustrates the fundamental law that pressure exerted on a confined liquid is transmitted undiminished in all directions and acts with equal force on all equal areas. This means that the pressure applied to a liquid at one point will be transmitted to any point the liquid reaches. If the pressure is applied on piston A, as shown in this illustration, piston B will apply the same pressure on any object with which it is in contact. This procedure may be reversed. The original pressure can be applied on B, and A will perform just as B did previously. This fundamental law means that the pressure of a liquid can be piped around corners. It can transmit force from point A through a pipe or flexible tubings to point B, where work is performed, as shown here. This law can be used to multiply force, because the law states that equal force is exerted on equal surfaces. This means that if the surface area of the large piston in this picture is 10 times greater than the surface of the small piston, then the total force exerted by the oil will be 10 times greater than the total force which the small piston exerts. As shown in this diagram, the lifting mechanism of the Toyota forklift truck applies the fundamental principle most effectively. You can clearly see that it operates on the fundamental law underlying the whole science of hydraulics and is used not only to transmit force, but also to change a small force into a larger one. Some hydraulic medium or oil circulates through the various parts within a system. To be at all practical, even the simplest hydraulic system must have these 5 essential elements. 1. Oil storage tank or reservoir to hold a supply of hydraulic oil. 2. A pump that moves the oil under pressure. 3. One or more appropriate valves to control the pressure, the rate of flow, and the directions of flow. 4. Hydraulic actuators to turn hydraulic power into mechanical force. And 5. Enough piping or tubing, shown in this picture by arrows, to connect the various parts, including supplementary lines for returning overflows back into the reservoir. As we are primarily interested in the design and construction of these parts and the functions they are designed to perform in practical forklift trucks, we would like to review what happens to the fluid during the normal cycling of the system. Reservoir. An essential part of any hydraulic system is the reservoir or tank. In the Toyota forklift truck, the tank is usually located within the right-hand section of the frame. It is made integral with the frame by welding and is protected by impact-proof frame members, which are steel plates as thick as 6 millimeters. The pump inlet line extends well below the fluid level and has a strainer known as a suction filter. This prevents contaminants in the fluid from entering the pump, thus protecting the system components. The strainer has a fine mesh screen to serve this purpose. After the hydraulic fluid is cleaned by the strainer, it is drawn into the working pump. Oil pump. The pump can be compared to the human heart. It is a mechanism that is used to lift and transmit the fluid. The pump used in the Toyota forklift trucks, which we are here studying, is an external gear pump. It forms a compact and very solid unit. In the illustration, the arrows show the directions in which the fluid is moved through this unit. The pump is suitably designed for high-pressure application and uses the pressure loading technique to minimize internal loss and maximize its volumetric efficiency. A bushing is arranged on each end face of the 2 meshing gears, as shown in the illustration. The pump is driven by the engine. The drive force is taken from the crankshaft through a large idler gear, as shown here. When the engine starts, the drive gear A and the driven gear B rotate in opposite directions, as shown by the arrows. The mechanical action of the pump forces the fluid from the inlet to the outlet of the pump. While the gears are revolving, the fluid accumulates on the outlet side and is forced out of the pump into the hydraulic system. Oil control valve unit. The fluid runs under relatively high pressure and enters the oil control valve unit at port A. This unit contains the valves to control the pressure and to direct and control flow of the fluid into the actuators, such as the lift and tilt cylinders, as required to do certain work. Valves also control the pressure and direct and control the flow of the fluid into the power steering booster cylinder. The excess flow and the fluid from the working cylinders are diverted into the reservoir through outlet. Forklift truck hydraulic system, provision is made for blocking the fluid flow from the tilt cylinders. This keeps the tilt cylinders hydraulically locked and prevents the entire mass from swaying forward by improper operation of the tilt control lever, even if the engine is at rest. This safety feature, which is known as the tilt lock valve, is built in the tilt valve spool as shown in this picture. The relief valve is a pressure-operated valve to make certain that the system pressure does not exceed specified safety limits. It is intended to relieve occasional excess pressures which arise during the course of normal operation. In the design we are studying, a pair of relief valves are installed in the unit. One is in the lift cylinder circuit and the other is in the tilt cylinder circuit. Fluid in the pressure line is diverted into the reservoir, limiting the pressure in the system and protecting the pump and system components against overload. This picture illustrates that most of the fluid is allowed to return to the reservoir through the outlet port of the unit when these spools are in the neutral position. As we have seen up to now, there are several valving elements arranged in one unit, each designed to perform a specific function. It should be noted, however, that the control valve unit used in this forklift is designed to permit easy additions of extra control valve spools to the existing unit. It is possible to install additional circuits for power-operated attachments without the need of replacing the entire existing unit. Such extra valves to be installed later on the unit are called add-on type attachment valves. Lift cylinder. Now we will discuss the hydraulic actuators. As we are primarily interested in the linear motion device, generally known as a cylinder, we will review the design of the lift cylinder. As you are aware, the lift cylinder is one of the most important functional parts of the lifting mechanism of the forklift. This device is responsible for converting hydraulic energy into mechanical motion that is required to move the load up and down. The lift cylinder is a single-acting piston type in which hydraulic pressure is applied in an upward direction only. In this illustration, the cylinder is identified by A. It is a rigid steel tubing, bored and honed. Enclosed in the cylinder is a piston B with U-type piston packing C, and a rod which extends out of one end of the head connected to the piston. In the bottom of the cylinder, there is a special built-in valve called a flow regulator, shown at D. Fluid delivered from the pump to the control valve unit is directed into the lower chamber of the lift cylinder, running past the flow regulator valve D. Fluid pressure admitted into this end of the cylinder pushes the piston upward when the control lever is moved to the lift position, and the lifting mechanism causes the forks to rise. When the lever is moved into the lower position, the control valve spool is moved into a position so that the fluid may pass through the flow regulator valve via the control valve unit into the reservoir. Now the forks, with or without load, are lowered. The flow regulator valve D is designed to limit the outgoing fluid from the lift cylinder, thus allowing the forks to be lowered at nearly constant speed under varying weights of the loads on the forks. This is a valuable safety feature that permits smooth handling of the heaviest loads without dangerous high lowering speeds. Tilt cylinders. The tilt cylinders are double-acting cylinders in which fluid force can be applied in either direction. They are highly rugged piston and cylinder combinations. As can be seen from this illustration, the major construction features are the cylinder A, piston B, piston rod C, and two U-packings D. As mentioned earlier in this study, the pump delivery is directed into either end of the tilt cylinder depending upon the positions of the tilt valve spool in the control valve unit. There is a tilt cylinder on both sides of the truck to provide better mast stability. In the Toyota forklift trucks, the rear ends of the tilt cylinders are pinned to brackets, which are welded to the truck frame, and the piston rods are connected to the outer mast members. With this arrangement, the entire mast assembly can be canted forward and backward as the piston rods extend and contract. As has been seen in the control valve unit, the tilt lock valve keeps these tilt cylinders hydraulically locked so that the load can be handled with stability and without the possibility of mast sway. Power steering. When the size of a vehicle becomes large and the weight becomes heavy, particularly in the case of forklift trucks whose wheels have to bear heavy loading, it may be necessary to employ power steering. Power steering makes it easy for the operator to steer the truck. The manual effort required to turn the steering wheel is much less than when assistance by power steering is not included in the steering system. Easy, smooth steering means higher working efficiency, less handling hazards, and reduced operator fatigue. The Toyota forklift trucks we are studying here have a power steering mechanism operated by oil under pressure in the steering system. The principal parts of the power steering mechanism are the power or booster cylinder A, whose piston is connected to the steerage linkage and the control valve unit B. As we have already seen in this study, fluid under pressure to operate the power cylinder is supplied from the flow divider housed within the control valve unit. From the flow divider, the fluid is delivered to the control valve, which is attached to the end of the steering gear box. The main function of this control valve, A in this picture, is to direct oil under pressure into the appropriate end of cylinder B when the steering wheel is turned by the operator. Power cylinder A is essentially a double-acting type. As shown here, the piston rod is connected to the steering linkage, and as it moves in and out, the rear wheels are turned to either side to steer the truck. The common means of connecting these components of the hydraulic system are piping, tubing, hoses, and fittings. In addition to the properly selected steel piping, the major part of the hydraulic piping is formed with high-pressure flexible hoses which are constructed strong enough to withstand high-pressure cycling. These hoses are rubber, which does not react with hydraulic oil, and which is not changed or damaged by high hydraulic pressure. Further, it is little affected by temperature changes. In order to ensure reliable, long-lasting performance and to give better leakage control, fittings with O-ring seals are used in the Toyota forklift truck wherever applicable. The study of the major features of the hydraulic system used in Toyota forklift trucks has now been completed. You are well aware that the proper use and maintenance of hydraulic systems depend on a thorough knowledge of the construction and functions of the system components we have studied. It must be emphasized here that to operate and maintain this important hydraulic system, you must know the basic laws of fluid power and must be familiar with how the basic components are interrelated with each other and how they work together in the hydraulic system of the actual forklift trucks you are going to work on. The components of the hydraulic system are all precision machined to close limits and are carefully assembled. They require good care to ensure and maintain satisfactory performance. Finally, we would like to point out some essential jobs that can be easily performed by the user during daily operation. The first job is to check the fluid level in the reservoir. Using the level gauge, ensure that the reservoir is filled with the correct volume of fluid and add fluid if necessary. At the same time, it is necessary to check the condition of the fluid. If heavy contaminants are noted, the fluid has to be changed. It is essential that the hydraulic piping is leak-proof. Check to see that the pump, the lift and tilt cylinders, and the connecting lines are free from any signs of abnormal condition. When inspecting the lift and tilt cylinders, ensure that they have no defects, particularly that the piston rod is not bent. During the course of normal operation of the forklift truck, be on the alert for strange noises or excess vibrations. Do not operate the forklift if such conditions are present. Immediately locate the causes of such trouble and make the necessary repairs. Our study of the Toyota forklift truck is now completed. The purpose of this study is to help you understand how important a role the hydraulic system of the forklift truck plays in the operation of the forklift. We sincerely hope that you will go further into details concerning Toyota forklift trucks, keeping the importance of the hydraulic system in mind. Thank you very much for your attention.